Hello everyone. In this video I'm going to discuss and summarize the properties of rhombuses, and then I want to do two examples using some of those properties. So first of all, a rhombus is a parallelogram, so all of the properties of a parallelogram also apply to a rhombus. So let me just summarize those. So this is a parallelogram. So the definition of a parallelogram: the opposite sides are parallel. So we know this. So we know AB is parallel to CD, and we know the other pair of opposite sides are parallel. Also with parallelograms, we have a couple different properties, like the opposite sides are congruent, and the opposite angles are congruent. So angle A is congruent to angle C, and angle B is congruent to angle D. And also with parallelograms, if I draw in the diagonals, we know that the diagonals bisect each other. So let me just draw in this other diagonal. Then let's label this point of intersection here. Let's just say that's point M. So AM is congruent to CM, and then for the other diagonal, DM is congruent to BM. Alright, so it's a parallelogram. All the properties of parallelograms also apply to rhombuses. But furthermore, we also have the definition. So the definition of a rhombus says that that all four sides are congruent. So parallelogram, the opposite sides are congruent, but in a rhombus, all four sides are the same. So that gives us AB is congruent to BC, which is congruent to CD, which is congruent to AD. So this is equilateral. Okay? And then from there, that's special for rhombuses. And then furthermore, we have a couple theorems that give us a few more properties. So the first theorem is the rhombus diagonals theorem. This theorem states that the diagonals of a rhombus are perpendicular. So that means we get four right angles in the middle of our rhombus. So in other words, AC is perpendicular to BD. So when we draw on the diagonals of a rhombus, all four of these triangles end up being small right triangles. Also, we can conclude from that as well, because we know the diagonals are bisected, so these segments are congruent, these ones are congruent as well. They're right triangles. We can see that all three sides are congruent, so by side, 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 all four of these triangles are congruent to each other. And the other property we have for rhombuses, the other theorem, is the rhombus opposite angles theorem. This one states that the diagonals bisect the pair of opposite angles. So this diagonal, for example, BD, this diagonal bisects angle D, and it also bisects angle B. So that means this angle and this angle, so on either side of that diagonal at D, those two angles are congruent. And then the same thing up at angle B. I also know that B and D are congruent to each other, so that means all four of those angles are the same. And the same thing works with our other diagonal here. So on either side of this diagonal, these two are the same. And then on either side, up at angle A. So we have these four angles are congruent, and these four angles are congruent. So to kind of summarize that property, diagonal AC bisects angle DAB, and it also bisects angle DCB. So that means angle DAC is congruent to angle BAC, and those are congruent. So that's DAC, BAC. Those are congruent to angle DCA and angle BCA. So those four angles. And the same thing for our other diagonals. So BD bisects angle ADC, and it also bisects angle ABC. And then that also leads to four congruent angles. And I'll summarize those here. So angle ADB is congruent to angle CDB, and those are all congruent to angle ABD, and that's congruent to angle CBD. So lots of properties of rhombuses. So again, everything for a parallelogram, that all applies. We have the definition that says that all the sides are the same. And then our special properties, the diagonals are congruent. The diagonals also bisect opposite angles. So let's use some of those properties in some examples. Okay, for both these examples, I just want to find the measures of these angles. So in this first one, we got the diagonals drawn in. We're given this one angle down here of 61 degrees, and I want to find the measure of those other ones. The first one is very simple. In the middle, the measure of angle 1, that has to be 90. So our property says that the diagonals are perpendicular, so all four of those angles in the middle are 90 degrees. Okay, second, the other theorem we took a look at, the opposite angles theorem, we saw that this diagonal bisects angle A and it also bisects angle C. So these four angles, the two on either side here, the two on either side here, these all have to be congruent to each other. So we know that the measure of angle 2 is equal to 61 degrees, and the measure of angle 3 is equal to 61 degrees. Another way we can think about that is we know that these are parallel. So the 61 degrees and then angle 2, those are alternate interior. So we know that these two angles have to be congruent. And then if I know that this is getting bisected, angle 2 and angle 3 have to be equal. So it has to also be 61. That just leaves one more angle, angle 4. I know angle 1 is 90. I know angle 3 is 61. So to find the measure of angle 4, we can use our triangle sum theorem. So 180 minus 90 minus 61. So 180 minus 90, that leaves me 90. And 90 minus 61, you get 29 degrees. So angle 4 is 29, which means that this angle is 29, and these two angles up here are also 29. And last one, doing the same thing. In this case, I am only given one angle, or one diagonal. I'm given the angle G is 118, and I want to find these four angles. Again, the opposite angles theorem for rhombuses says that, so angle D is bisected and angle F is bisected. So right away, I know that angle 1, 2, 3, and 4, I know that all of these angles are equal to each other. So if I can find one of them, I know all of them. Okay, so I'm just going to focus on half of my rhombus here. So if I look at this triangle DGF, because it's a rhombus, I know that that triangle is an isosceles triangle. And these two angles have to be congruent. So if I use the triangle sum theorem, so if I do 180 minus 118, that leaves me with 62 degrees. Okay, so that means that I need to split up that 62 degrees equally among these two angles. So 62, we'll cut that in half. So each of those angles is 31. So the measure of angle 1 is 31. The measure of angle 2, because these are bisected, that is also 31. The measure of angle 3 is 31 degrees because it was isosceles, so we know the base angles are congruent. And then again, the measure of angle 4 is also 31. So using the properties of rhombuses and a couple of those theorems, we're able to find out a lot of information here.